function is maxima or minima. All those points in the interior of an interval where f dash x is either equal to 0 or does not exist are called critical points, right? And how to check maxima and minima? If fx is a continuous function in the neighborhood of a point x is equal to a, such that f dash x is equal to 0. To find the critical point, you use this f dash x is equal to 0, right? And for finding whether the function is maxima or minima at the given point, we check the sign of double derivative of function at point A. So we know that if f double dash a is greater than 0, then x is equal to is a point of local minima. And if f double dash a is less than 0, then x is equal to a is a point of local maxima. And if f double dash a is equal to 0, then second derivative test does not give conclusive results. Right? This we have done. So to find whether the function is maximum or minimum at the point, first we need critical points, right? And at those critical points, we can check whether function is maximum or minimum. For that, we do what? We do this second order derivative test. If second order derivative at point A is greater than 0, then x is equal to a is the point of local maxima. If it is less than 0, then this is the point of local maxima. Greater than 0, minima. Less than 0, maxima. And if it is equal to 0, then it will not give you any result. So let us have one example. Test the following function for maximum and minimum value. This is your given function. So for finding critical point, we will do first order derivative test. So we will be finding its derivative. 15x power 4 minus 15x square, and x square minus 1 can be written as x minus 1 x plus 1. So from here you are getting 3 point, x is equal to 0, x is equal to 1 and x is equal to minus 1. Right? So you will be having these three critical points. Done. Second task is second order derivative test. So you need to find out its second order derivative. So that would be 60x cube minus 30x. Now we will be checking this second order derivative at point 0, 1 and minus 1. So when you are putting x is equal to 0, it would become 0. It means x is equal to 0 is neither maximum point or minimum point. Now, next for x is equal to 1, we will be putting x is equal to 1 in this. So you will be getting here 60 minus 30, that is greater than 0. If it is greater than 0, then x is equal to 1 is the point of minima. Similarly, next, this is the f double dash x. Put x is equal to minus 1. And that would be your minus 30. It is less than 0. So this is the point of maximum. This is what you have done in your previous classes, how to find or how to check whether function is maxima or minima, or to find the minimum or maximum value of given function at any point, right? Now we need to extend this idea up to function of two variables. This was up to function of one variable, and now we need to move to function of two variable. Maxima and minima for function of two variables. Let z is equal to f of x comma y be a function of two independent variable x and y. Relative maxima or local maxima, both are the same thing. If f of x comma y is said to be a relative maxima at a point a comma b, if value of function at this point is greater than value of function at point a plus h comma b plus k. It means, let us suppose this is your point a comma b. I'm saying this function is maximum at this point, right? And when can I say that? When can I say that this is the maximum point? When value of function at this point will be more than value of point, all the points lying in its neighborhood. Value of function at this point is more than or highest than all other points in neighborhood of it, right? So what is this a plus h or b plus k? This is change in a and change in k. It means this is the neighborhood of a comma b, and there are so many points here: a plus h, b plus k, a minus h, b minus k. This h and k may be positive or negative for small positive and negative values of h and k. So we will be considering all these points. Value of function at all these points must be less than value of function at this point, right? Value of function at these point must be less than value of function at this point. Then only we can say that function is maximum at this point, right? Similarly, relative minima. So let us having like this, right? You are having a ball in your hand, right? You are having a ball in your hand. So when you are taking this ball in your hand, so this is your point when value function is minimum, right? So let's say this is the point a comma b. Value of function at this point must be less than value of other points that would be in the neighborhood of a comma b, right? So this is the neighborhood point of a comma b, and this is also neighborhood of point a comma b. इन सब पॉइंट पे फंक्शन की वैल्यू क्या होनी चाहिए? ग्रेटर देन होनी चाहिए देन दिस वैल्यू function at this point. So for this definition, what we are saying, in the neighborhood, value must be greater than this. So value of function at the neighborhood must be greater than this for positive and negative h and k. Then function is said to be minimum at this point. Is it clear? Is it clear, beta?
Yes, ma'am.
Okay. So next is extremum. Extremum is a point which is either maximum or minimum. Extremum is a point which is either maximum or minimum. The value of function f at extremum point is known as extremum value. This extremum is a point at which function either maximum or minimum. And extremum value is what? That is maximum and minimum value of function, right? There is a difference between extremum and extremum value. Extremum value means maximum or minimum value of that function, and extremum means the point at which function is going to be maximum or minimum. So this was the example we have already discussed. Because z is equal to f of x comma y geometrically represent a surface, right? तो हमने क्या लिया? हमने एक बॉल ले लिया जो हम घर में यूज करते हैं, एक बाउल. उस बाउल को अगर हम सीधा रख देते हैं तो दिस पॉइंट वुड बी मिनिमम. उसी बाउल को हमने अगर उल्टा कर दिया सो दिस पॉइंट वुड बी योर मैक्सिमम पॉइंट, राइट? नेक्स्ट इज सैडल पॉइंट. सैडल पॉइंट इज अ पॉइंट वेयर फंक्शन इज नीदर मैक्सिमम नॉर मिनिमम, in which function is going to the in the positive direction and other way it is going to the negative direction. So it is neither maximum nor minimum. So that point is known as saddle point. Somewhere function is going to increasing and somewhere it is going to decreasing, right? So such point is known as saddle point. Now, how to find the extrema for function of x comma y? To find the critical point in the function of single variable, we use first order derivative test. That would be f dash x is equal to 0. Right now, we have discussed to find the critical point, we use first order derivative test. That means f dash x is equal to 0. So what will we do here? Because we are dealing with a function of two variable, So when you are dealing with the function of two variable, there would be two first order partial derivative. One is fx, another is fy. So to find the critical point or stationary point, we will be putting fx0 or fy0. Right? In one variable, we do like this. F dash x is equal to 0. That is your first order derivative test. अभी यहाँ क्या है? We are dealing with function of two variable. So that is why here two first order partial derivative will exist. So we will be putting here fx is equal to 0 and fy is equal to 0. The first step to find the critical point or stationary point, we will put fx is equal to 0 and fy is equal to 0, and then we will solve it. And from here we will be getting critical points. Right? Then after this first order derivative, for checking the maxima and minima, you have used double derivative at that point, right? In case of single variable, we do have only one second order derivative. But in case of function of two independent variable, how many derivative do you have? How many second order derivative we do have in case of function of two independent variable? Yes, please.
3.
Which three, beta?
fxx, fyy, and fxy.
fxx, fyy, and fxy. Why not fyx, beta?
For
Why not?
continuous function, they both will be same.
Both will be same, but they exist, na beta?
Yes, ma'am.
So there are four second order partial derivative. So we need to use all four, right? Let us see how we will use all four. Calculate R, that is fxx. So fxx is known as R. We will be giving a name to this second order derivative, that is R. Then S, this is your S. And then T, this is your T. Right? Calculate R, S, and T at the critical points. Whatever critical points you are getting from after solving this, we will find R, S, and T at that point. Then, function has maximum value at point A comma B if, let us see here, R into T minus S square. Why I am saying S square? Because there are four second order derivatives, so we need to use all four, but we know that they both are same. Both are same in case of continuous function. So that is why we are putting here RT minus S square. R is what? Fxx, T is what? Fyy, and S is what? Fxy. So you need to check the sign of RT minus S square. It must be greater than 0, right? It must be positive or greater than 0. If it is greater than 0, then only we will be checking whether the function maximum or minimum. If it is less than 0, then you need to write here it is a saddle point, right? So if it is greater than 0, RT minus S square is greater than 0, then after that you need to check the sign of R. R is what? Fxx. If this R is less than 0, then function has maximum value. If RT minus S square greater than 0 and R greater than 0, then function has minimum value at that point, right? So you will remember it in this way. We do have four second order partial derivative, and how we arrange them: R into T minus of S square, R into T minus of S square. और आर एस टी कैसे लर्न करना आपने? दिस इज एक्स एक्स, देन एक्स वाई, देन वाई वाई. जैसे अल्फाबेटिकली ऑर्डर है आपका, वैसे आप इसे लर्न करोगे. एक्स एक्स आर, एक्स वाई एस, वाई वाई टी. So r into t minus of s square. If it is greater than 0, then only you will be checking whether it will be maximum or minimum. That depends upon sign of r. If it is negative, it is less than 0, तो आपके पास फंक्शन क्या होगा? मैक्सिमम. इसका ऑपोजिट, अगर ये लेस देन जीरो है तो यहाँ मैक्सिमम रहेगा. If ये greater than zero, then it would be minimum, right? And if it is less than zero, it means it is a saddle point, neither maximum nor minimum. And if this is equal to zero, exactly zero, then further investigation is needed to determine the nature of function, whether it will be going to the maximum or minimum. We are not sure when it is equal to zero. Is it clear? So first step is you need to find out the critical point. Second step is you need to find out second order derivative at all the critical points. Then you will be checking the sign of rt minus s square. If it is greater than 0, then you need to check the sign of r. If r is less than 0, function having maximum value. If r is greater than 0, then function has minimum value. If rt minus s square less than 0, it is a saddle point. If rt minus s square is equal to 0, it means further investigation is needed. Right? I hope method is clear. How to find extrema for function of x comma y. Now let us have an example. Now you will solve all the derivative and you will be telling me what value you are getting, right? Find the values of x and y for which function u, that is x square plus y square plus 6x plus 12, has a minimum value, and find its minimum value. So first step is you need to find out critical points. For critical points, what condition you will be putting here? Yes, Akash. Akash. Abhinav. ID number 47. Yes, Akash, please. Abhinav. 47 ID. Okay, 46 ID.
Yes, yes, ma'am.
Tell me, beta, what are the conditions to find the critical values?
Hello.
Am I audible, bache? Okay, there is some issue. Abhishek. It's okay, Abhinav. No issue, beta. You can mute yourself. Abhishek, ID number 40.
Yes, ma'am.
Tell me, beta. First step, we need to find out the critical points. And what are the conditions for to find the critical points? Anyone who can tell me what are the conditions to find the critical point?
Ma'am, f of x is equal to 0 and f of y is equal to 0.
Very good, beta. F of x is equal, f of x means partial derivative of function with respect to x, that would be equal to 0. And f of y, that is derivative of function with respect to y, that would be 0. See, this is u. U is a function of two independent variable, x as well as y. It means you are dealing with function of more than two variable, right? So Aditya told me first condition to find the critical point, that is ux is equal to 0 and uy is equal to 0, right? So find out ux is equal to 2x plus 6, 2x plus 6, uy 2y, that's all. Baki sab 0. This is 0, this is 0, and this is 0. So now put ux is equal to 0 as well as uy is equal to 0. To find it would be maxima or minima, we have this ux 0 and uy 0. So you'll be putting 2x plus 6 is equal to 0 and 2y is equal to 0. So from here, y is equal to 0 and x is equal to minus 3. So this minus 3 comma 0 is your critical point at which you need to check whether this function is minimum or maximum. Right? It is mentioned already in the question, it has a minimum value. So we will check. Now, you need what? Next you need R, S and T. What is R? R is, here I am writing U is a function, so UXX. Right? What is S? U, X, Y. What is T? U, Y, Y. Right? You need this R, S and T, all three derivatives at point minus 3 comma 0. Right? And then you need to check sine of RT minus of S square. Now hurry up, find R. Find R. R is what? UXX. UX you have already evaluated. So what will be the UXX? Yes, what will be the UXX?
2.
2. You will be differentiating this again with respect to x, so that would be 2. So UXX at point minus 3 comma 0, it will remain as it is 2. Similarly, next UXY. What it would be? UXY.
0.
0. Ux already is there and you will differentiating it with respect to y. To everything is constant, value would be 0. Next, Uyy.
2.
2. This is 2. So Uyy at point minus 3 comma 0, it would remain as it is 2. Right? Because there is no x, no y. So you have calculated this is r, this is s and this is t. So now check the sign of rt minus s square. R into T is 4 and S is 0. So that is equal to 4, that is greater than 0. Right? RT minus S square is greater than 0. Then you need to check sign of R. What is R? R is 2 and that is greater than 0. If it is greater than 0, RT minus S square greater than 0 and R greater than 0, this implies function has minimum value at point minus 3 comma 0. Right? So let us have this. This is R, S and T. You have checked R into T minus S square, that is 4 greater than 0 at x minus 3 and y is equal to 0. So R is greater than 0. So therefore function is minimum at this point. Now find the minimum value of function. Put this x minus 3, y is equal to 0 in your function. This is your function. Put the value x is equal to minus 3 and y is equal to 0 and let me know what will be the minimum value. Yes, beta?
Ma'am,
What?
it's 3.
3 beta? No. Okay, let's check it. So it is 3. 9 minus 18 plus 12, that is 3. So minimum value is 3. I hope question is clear. Easy. First, you need to find out the critical point. You will find the critical point using first order derivative. That means ux0, uy0. And then you need to find out second order derivative, rts. And accordingly, check their sign. And then you can tell whether the function is maximum or minimum. Right? Let us have one more example. Find the maximum or minimum value of x cube plus y cube minus 3axy where a greater than 0. Yes, tell me, what will be the first step? Prikshit?
Yes, ma'am.
Tell me, beta, what will be the first step?
Ma'am, u is equal to x cube plus y cube minus
Done.
3xy.
Yes,
Then,
बच्चे.
then differentiating. Oh, ma'am, critical point ux is equal to 0 and uy equal to 0.
Good. Tell me what is ux? What will be the ux?
Ma'am, ux will be 3x square
Hmm.
minus 3ay
Yes. And uy?
2y square.
2y square or 3y square?
Ma'am, 3y square, sorry.
Yes, 3y square.
3y square and 3ax.
Yes, minus of 3x. Good, beta.
3ax.
Thank you. So we will be putting this is equal to 0 as well as this is equal to 0. And we need to solve this simultaneously. So x square minus or is equal to ay. From this equation, you will be getting this. And from second, you will be writing this y square is equal to ax. Right? And then you need to solve it. So how do we solve it? You can get the value of x from here and put it here. So what is x? X is equal to y square upon a. So now put this equation over here. So you will be getting here y power 4 is equal to a cube into y. Right? We have evaluated ux, uy. Equate this is equal to 0, equate this is equal to 0. And from here, you'll be getting x square is equal to ay. And from here, y square is equal to ax. So you need to simplify these equations simultaneously. So you will be putting value of x from here and put it in other equation. Or other way you can do it, get the value of y from here and put it here. So from here, what you will be writing? Y is equal to a. Right? Now let us see here. This is your u function. We'll be finding ux, uy. Equate this is equal to 0, this is equal to 0. So from here, you are getting x square is equal to ay, y square is equal to ax. And then you are writing this x power 4 is equal to a square, y square means squaring it both side and use this y square is equal to x over here. So you will be getting here a cube x. So x would be cancelled out. X cube is equal to a cube. This implies x is equal to a. Right? So after getting this x is equal to a, get the value of y. So this implies y is equal to a. X is equal to a. So it become a square is equal to ay. And from here, you can write y is equal to a. Right? So you'll be getting this point, x is equal to a as well as y is equal to a. So now your critical point is a comma a. Done. Next, find r, s and t at point a comma a. Yes, now tell me, who will be telling r and s and t? Evaluate it, hurry up. Take 1 minute. We know that r is what? ux6. S is
Right.
what? uxy. And t is what? uyy. Find out, hurry up. Vanshaj,
Yes, ma'am.
tell me beta what is R?
मैम मैं निकाल रहा हूँ अभी.
निकालो, मुझे बता दो बेटा यहीं पे. हमारा UX ये था probably, right? You just tell me what will be UXX. Differentiate it with respect to X.
Okay.
What will be the differentiation of 3x square?
Ma'am 6x.
6x. And what will be the differentiation of minus 3ay?
मैम इसका कांस्टेंट नहीं.
Constant है तो it would be 0.
Yes.
Right? It means you'll be having R is equal to 6x and you need. So it would be 6a.
6.
Done?
Yes.
Now find out SNT. Yes. What is S beta?
minus 3a.
मैम -3 है.
Minus 3a. And what is T?
मैम 6y.
6y.
6A, ma'am. 6A.
6a है ना? At the place of y you need to put a.
Yes.
Correct? So
Yes.
let us check it. 6x 6y minus 3a. So we will be finding all the derivative at point x is equal to a and y is equal to a. So you will be getting this. Six a and 6a. So when you are getting r into t minus of s square, it would be 36a squared minus of 9a square, right? So ultimately this would be value rt minus, this is r t minus s square. So that is 36a square minus of minus 3a square, 9a square, 27a square, that is greater than 0, right? Now, you need to check the sign of r. R is what? 6a. Tell me now. It is greater than 0 or less than 0?
Ma'am, greater than 0.
Greater than, ma'am.
Why it is greater than 0?
Because A is greater than 0.
Yes,
And 6 is
because
also.
yes, because in question it is mentioned a greater than 0. If it is not mentioned, right? If it is not mentioned, then you need to mention here it would be greater than 0 if a greater than 0, and this would be less than 0 if a is less than 0. Then you need to make two cases and explain accordingly. But right now it is greater than 0. So what is the case, Viche? This is greater than 0, this is greater than 0. So it would be maximum or minimum?
Minimum.
Minimum, right? So function would be minimum at point a comma a. And what will be the minimum value? Function is our x cube plus y cube minus of 3a xy. है ना? So we will be putting a over x is equal to a, so a cube plus y is equal to a cube minus of 3a cube. So answer would be minus of a cube, right? Not minus 2a cube, it would be a cube. So minimum value would be minus of a cube. Is it right? Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Chalo. Now come to the next question. Divide 120 into 3 parts so that The sum of products taken two at a time shall be maximum. Divide 120 into three parts so that sum of the products taken two at a time shall be maximum. Anyone who can explain this question? How to proceed? Divide 120 into three parts. So can I write like this? X plus y plus z is equal to 120. Right? Then sum of the product taken two at a time. Sum of product taken two at a time. So I'm taking these two, xy plus yz plus zx. These two are taken at one time. Product is taken, and you need to take the sum. This shall be maximum. So this is your function which you need to show that this is maximum. Is it right? But we do have the formula, or we do have the process for finding maximum or minimum value for function of two independent variable. So here z is creating problem. So my first task is remove this z. So can I remove this z? Can I replace this z?
Yes, ma'am.
Yes. So you can get the value of z from here and substitute it over here. Right? So function would be x into y plus y into 120 minus of x minus of y plus x 120 minus of x minus of y. So this become your question now. This is your fx comma y. And after that, you need to proceed in the similar way. So let us start this question. Let 120 is equal to x plus y plus z. This is the sum of product. So you need to remove z from this function. So you are putting z is equal to 120 minus x minus y. Put it here. So this is your new function now. P is equal to xy plus y times of 120 minus x minus y plus x times of 120 minus x minus y. So now take 1 minute and then evaluate px and py, equate to 0 and get the critical points. जो सबसे पहले करेगा वो बताएगा मुझे try it. Put px is equal to 0, find py and put py is equal to 0.
Y plus Z is equal to 0, X plus Z is equal to 0.
Z तो नहीं आएगा बेटा. We have removed the z.
Sorry, sorry कर दिया.
Z को remove करो, इसका derivative करो with respect to x. So probably you'll be getting y plus y into minus 1 plus x as it is. इसका differentiate करोगे, it would be minus 1 plus 120 minus x minus y as it is, and then y. Then you need to simplify it. So this would be cancel out, and probably you'll be having 120 minus 2x minus y. Simplify it in this way. Anyone who has done px? Derivative of p with respect to x?
Yes,
Yes, beta. Tell me.
ma'am, it's 120 minus 2x minus y.
120 minus 2x minus y. Correct. Similarly, py 120 minus x minus 2y. I hope, Ishita, you're getting same.
Yes, ma'am, same.
Okay. Now try to solve these for x and y. You'll be putting this is equal to 0 and as well as this is equal to 0. So from here I'm writing 2x plus y is equal to 120 and then x plus 2y is equal to 120. So you need to simplify these two equations and get the value of x and y. Hurry up, solve it.
Ma'am, x and y both out to be 40.
X and y both are 40. Okay. So this is the condition px is equal to 0, py is equal to 0, and after solving these two equations, you will be getting x is 40 as well as y is 40, right? And we know that x plus y plus z is equal to 120. So in that case, this is 40, this is 40, to z will also 120 minus 80, that would be 40, right? So now next, you need to find out pxx, pxy, pyy at point 40 and 40. Find everything at point 40 and 40. Right? So find it out. From here, pxx, that would be minus 2. Then pxy, it would be minus 1. And then pyy, that would be minus 2. Right? So r is minus 2, t is minus 2, and s is minus 1. Right? And all values at 40, 40 would remain same because all are constant. So now check rt minus s square, r into t minus of s square. So this into this is equal to 4, minus of minus 1 square 1, that is equal to 3. So it is greater than 0. Rt minus s square greater than 0, then you need to check the sign of r. R is what? Minus 2, that is less than 0. So what is the case? This is the case of maximum or minimum?
Maximum.
Maximum, right? If r is less than 0, then this is maximum, and we need to show that the sum of product taken two at a time shall be maximum, right? So you have evaluated all this derivative. We have calculated this, then we have checked this is greater than 0, this is less than 0. So function is maximum at x is equal to 40, y is equal to 40, and z is equal to 40. Right? I hope it is clear. Now, note it down. You need to practice for all these questions. You can click it because sometime it happens PDF late हो जाता है आपके लिए. So please click it and practice for these questions. Done? Done, beta? Have you taken the picture?
Yes, ma'am.
Yes, ma'am.
Okay. Now, come to the next. That is Lagrange method of undetermined multiplier. Lagrange method of undetermined multiplier. In many practical or theoretical problem, it is required to find maximum or minimum value of a function of several variable. Till now, we have done how to find the maximum minimum value of function of two variable. But sometime it happen we need to find out maximum or minimum value of a function of several variable, right? In that case, we use Lagrange multiplier method. where the variables are connected by some given relation or condition. But it is possible when there is some constraint or condition is given between those variables, right? For example, for a function of three independent variable, x comma y comma z, the problem of constraint extrema is to find the extrema of this. This is your function and constraint is given by this. You need to find out the maximum or minimum value of this function under this constraint. So such type of problem we can solve using Lagrange multiplier method. Right? Lagrange multiplier method. So what is this method? Step number 1, let this f function which is to be optimized, right? Subject to the constraint this. You need two things, right? There is two things are mentioned in your question. First, one function for which you'll be finding maximum or minimum value, and another is constraint. So whenever question is given to you, you need to check it out, or you need to find out what will be your f and what will be phi. What will be f and what will be phi. If you are choosing correct, then there is no problem. Very simple, right? So you need to choose that function as a f, which is to be optimized. Optimized means whether you are getting minimum or maximum value of that function. जिसकी भी value find out करनी है, you will be making that function as a f, right? And other given condition is represented by phi. That is your constraint, right? So step number 1, find Lagrange function. Lagrange function is this. Capital F is equal to small f plus lambda phi. Lambda is your multiplier, right? That is why this is known as Lagrange multiplier method. This is a multiplier, lambda is a multiplier. This function, which is maximum or minimum, and this is your constraint. First is construct a Lagrange function, then find auxiliary equation by differentiating it. To find the stationary value, we'll be putting df is equal to 0. So you are differentiating this. df means total differential, derivative of this with respect to x into dx, derivative of this with respect to y into dy, derivative of this with respect to z into dz. That is equal to 0. And from here, you'll be writing this is equal to 0, this is equal to 0, and this is equal to 0. Right? So you need to remember first thing, construct this Lagrange function, right? And then second, put this is equal to 0, this is equal to 0, and this is equal to 0. Means, what is it? Curly capital F upon curly x is equal to 0. Similarly, this is what? Curly f capital curly y is equal to 0. And this is curly f capital curly z is equal to 0. First, construct a Lagrange equation. Second, curly f by curly x plus lambda curly phi by curly x is equal to 0. Curly f by curly y plus lambda curly phi by curly y is equal to 0. Next, curly f by curly z plus lambda curly phi by curly z is equal to 0. Now, after that, using this second and this one, you need to solve for x, y, and z. Right? You need to solve for x, y, and z. Third is investigate further to optimize the function. What is the meaning of this? Sometimes it happens कि you can sometimes क्या rather this is the disadvantage of Lagrange method. You cannot tell them whether this function is going to be maximum or minimum, right? To do that work, you need further investigation. You need to do some investigation just to check whether this function is maximum or minimum. This is the disadvantage of Lagrange method. But what is its advantage? To find the maximum or minimum value of function, it is easy method. Calculations are very, very less, and we can easily evaluate value of x, y, z at which function is going to be maximum or minimum. Right? So these are the advantage. We can find the maximum and minimum value of function for several variable. or we can use it for n number of variable. Disadvantage, this doesn't enable us to find whether the function is maximum or minimum. We can determine that on the basis of physical consideration, right? And equation 2 conditions are necessary condition, not sufficient. Let us have one example. A rectangular box open at the top is to have volume of 32 cubic feet. Find the dimension of box requiring least material for its construction. Again, I am reading this. Read it carefully. A rectangular box open at top is to have volume of 32 cubic feet. Find the dimension of box requiring least material for its construction. So there are two things in your question. One is volume, another is least material required for its construction. That means its surface area. So let x, y, z be the edges of box and s be its surface. Now this is a rectangular box. So you tell me, what is the volume of a rectangular box? Yes. What is the volume of rectangular box? Yes, beta. What is the
LBH.
volume? Sorry, bache.
Length into breadth into height.
Length into breadth into height. So here, length, breadth, height, we have supposed x, y, z. So it means I can write it x, y, z is equal to 32. Is it right? Now, next. We need its surface area. So what will be the surface area for this box? Yes, beta, please tell me what will be the surface area of this box? Can you see this box? Why I'm making a dot? Just to tell you this is open at top, right? So how many faces this box having? How many faces?
5.
5, right? Open at top. So let us have, this is your x-axis and this is your y-axis. So this x and this y. So what is the area of this floor? Area of this base? X into y? Right now? Then plus, this is your z-axis, right? This z and this x. What is the area of this wall? Yes, it is a rectangle now.
ZX.
What will be the area, bacha? This is your z. So z into x? Yes or no?
Yes, ma'am.
So this is zx. जो एरिया इस वॉल का है सेम ही एरिया इस वॉल का भी होगा. तो can I write here 2zx? Now come to this front face. This front face. What is it? This is your y-axis and this is your z-axis. So area of this front wall, that is z into y. And similarly for back. So that is again 2zy. So this would be your surface area xy plus 2yz plus 2z. Is it clear or not? See, you are sitting in a room, right? And forget about roof. Roof नहीं है आपके पास. इस रूम में रूफ को छोड़कर आपके पास क्या बचता है? 4 walls and 1 floor, right? तो वही हमने बनाया यहाँ पर. ये आपका फ्लोर है. This one wall and this second wall. दिस इज फ्रंट वॉल एंड दिस इज बैक वॉल, सिर्फ हमारा टॉप नहीं है, राइट? तो आपने बेस में, ये जो आपका बेस था, ये एक्स को आप सपोज किया x और दिस वन इज y, तो नीचे वाले रेक्टेंगल का एरिया क्या हुआ, x इंटू वाई। मैंने यहाँ ट्वाइस नहीं किया, why? बिकॉज हमारे पास रूफ नहीं है, दिस बॉक्स इज ओपन, so that is why I am writing here 1xy. Then come to this wall. अब ये भी एक रेक्टेंगल की तरह है आपके पास वॉल, जिसका ये वाला एक्सिस क्या है, z, और ये क्या है, x. तो इसका एरिया कितना हुआ, z इंटू एक्स, this plus this. So we are taking this twice. Similarly, this is your front wall, right? This is your y and this is your z. So area of this rectangle would be y into z. Front plus back, that would be twice of zy. Is it clear or not? If these two conditions, how I'm writing this, it is clear, then only we will proceed further. Yes or no, it is clear or not?
Yes, ma'am, it's clear.
Okay. Now you will tell me, I have told you, first thing you need to make a Lagrange function. And in Lagrange function, we write two functions. One is small f and another is phi. Capital F is equal to small f plus lambda phi. Now you need to choose one function out of these two, one function as a f, another is phi. And I have told you this function would be that function which is going to be maximum or minimum. So now question is in front of you. You tell me what function is considered as f or what function is considered as phi. Just try it. Yes, beta. Which function will be small f and which function will be phi? You have two things, na? One is this s and one is this function. Or I am writing it like this. Phi is equal to xyz minus of 32 is equal to 0. Sorry, I'm writing it phi. Okay, abhi at right now I am writing it g. Yes, tell me. Okay, is it clear after reading the question ki what should be the least?
Surface area should be least.
Surface area should be least. It means surface area should be minimum, right? So we need to take this as a small f function because हमने इसको क्या बताना है, that is least. So whatever least or maximum, that will be considered as a small f. So this would be your small f function and this condition would be your phi function. So I'm writing it phi. If you are choosing this correct now, then there is no problem in solving. Is it clear? जिसको भी आपने maximum या minimum according to question evaluate करना है, that would be your small function f and other condition would be your function phi. Is it clear? Because here it is written least material for construction. It means least surface area. So surface area का जो formula है, that would be your small f. Another condition would be your phi. Right? So now let's see. This is 1, 2. This is your Lagrange function. F is equal to xy plus 2yz plus 2zx plus lambda xyz minus 32. This is your small f and this is your phi. Now next is curly f by curly x, capital F. So that would be curly f by curly x plus lambda curly phi by curly x and equate that is equal to 0. So this is your small f. Take it differentiation with respect to x. It would be y plus 2z, right? So y plus 2z plus lambda as it is and yz. Yz is equal to 0. Second condition, curly capital F with respect to y is equal to 0. So you'll be differentiating it with respect to y. It would be x plus 2z plus lambda xz is equal to 0. Similarly, curly f by curly z, that is equal to 2y plus 2z plus lambda xy is equal to 0. Now, with the help of this 3, 4, 5 and this given condition, you need to solve it for x, y and z. Right? You need to solve it for x, y and z. So how we are solving it? Multiplying 3 by x and 4 by y and subtract. So we're multiplying this with x and this with y and subtract it. So this is xy, yx. Both will be cancelled out. Okay, I'm writing here xy plus 2zx plus lambda xyz is equal to 0. And xy plus 2zy plus lambda xyz is equal to 0. And then subtract it. Minus, minus, minus. So this would be cancelled out, this would be cancelled out, and from here you'll be getting x is equal to y. 2zx minus 2zy is equal to 0, and from here x is equal to y. Right? Now similarly, you will be multiplying this with z. So using this and this. So you will be having again xy, I'm writing it here, xy plus 2zy plus lambda zxy is equal to 0. And then 2yz plus 2xz plus lambda zxy is equal to 0. Then subtract it. So this plus 2yz minus 2yz cancel. This would be cancelled with this. And from here you'll be getting y is equal to 2z. Right? So you will be having this relation as well as this relation. Using these three and this given condition, you need to find out x, y and z. So if x is equal to y is equal to 2z. So can I write z is equal to x by 2? Is it right? Z is equal to y by 2 and y is equal to x. Why I'm writing? Because I'll put x, y, z all in terms of x to get the value of x from this. So this x would be x and this y would be again x and this z would be x upon 2, that is equal to 32. So it means x cube is equal to 64 and therefore x would be 4. X is equal to 4, then y would be 4 and then z would be 2. Right? So you need this dimension of box. Find the dimension of box. It means you need to find out x, y, z, and you have evaluated x is 4, y is 4 and z is 2. Right? So I'm showing you from this first you are getting this x is equal to y. From here z is equal to 0, y z is equal to 0. This, if z is equal to 0, it become rectangle, height would be 0. So we cannot take z is equal to 0. That is why we are neglecting this. Similarly, from second, you are getting y is equal to 2z, and then this is the dimension. X would be 4, y would be 4, and z is equal to 2. I hope this question is clear, beta. Or other way to solve, you will try it yourself and I'll discuss tomorrow. What you can do it, you can get value of lambda from this and value of lambda from this, value of lambda from this, and then equate these two, get the relation between x and y, relate these two, get the equation y and z. It's your choice. You can solve either that way or this way. So that's all for today. Tomorrow we will continue with this Lagrange multiplier method. Any doubt? Any doubt in this question, beta?